for example 2, we're going to do b first. And the reason we're going to do b first is because there is a shortcut in a, but I want to show you the shortcut after we've practiced solving the steps properly again. So in part b, we have 3 equals log 2 of x plus 2 plus log 2. Do we have a single logarithm? No. We have 2 logarithms. So step 1, we're going to use our log laws. Are the bases the same? Yes. What's the log law for adding? The log law for adding says that if you're adding, you can multiply so inside I would have x times x plus 2. Once you have that single logarithm, you're solving for an x inside of an exponential function. This is the step. We take what we have and we write it. We multiply that out in exponential form. And that changes it from a log equation, and now we just have a quadratic equation to solve. How do I solve quadratic equations? I'm going to make one side equal to 0, so I'm going to subtract this 8. And you either have to factor, use the quadratic formula, complete the square, whichever method you like. This one looks like it factors nicely. I'll do plus 4 and minus 2. Oh. There, I just wanted the one step in purple. Just that step that we forget. Now once we've solved, we have to check. If I plug -4 back into my original equation, -4 plus 2 is -2. I don't even have to check the second part. I already know that that one will not work. If I plug in 2, 2 plus 2 is 4, positive number works there. Check it in the second one, 2, positive number there. This one works. But you have to check one of the things, and the textbook does a bad job of this, is the textbook in example 1, which answer didn't work? The negative one. In example 2, which answer didn't work? The negative one. You are students, you're very good at patterns, and so one misconception that comes up is students start to go, oh, so if the answer is negative, I just X it out? No. I can make a question where the negative one works and the positive one doesn't. You have to plug it in to check. And when you're plugging it in, you're checking to make sure that there's never a negative number inside of a logarithm. Just because the answer is negative, like I could have this. Let's say I have this, and my two answers were x equals -3 and, oops. Let's say I have this. There we go. X equals -3 and x equals 5. If you were checking this one, can you see the -3 actually works? Because this would be +4 inside. But the 5 would not work. So you're always having to check your original equation, not just assume that if the answer is negative, you can cancel it out. Okay. I'm going to erase this one, and then I'm going to do A, and I'm going to add the shortcut. A has 3 logarithms. And so, first of all, I could combine the logarithms on the right-hand side together. because we're adding. So the shortcut comes into play if and only if you have a single logarithm on the left-hand side, which we do. We have one log on the left and one log on the right. Okay? So I'm going to show you the shortcut. That's not to say that you still couldn't use all the steps. If you wanted to use all the steps, you'd have to get a single logarithm. We still have two logarithms. You'd have to subtract this to the other side, get all your logarithms on one side, and then put it together, and you could solve it that way. I will do that for this question afterwards to show you how you could use the steps. But the shortcut is really nice, and it looks the same as our shortcut for solving exponential equations. You remember when I would go, so, like that? Well, what do we have? I have a log on this side and 6x inside. I have a log on this side, and I have this inside. By observation, does it not make sense that the 6x inside of this side has to equal the x plus 6 and the x minus 1 on the other side? That's a shortcut. It's the same shortcut that we used when we had our bases the same and could like circle the exponents and say, so my exponents have to be the same because my bases are the same. But that only worked if you had a single exponential on each side. So it's very similar to that. Now, how do we solve this equation? Well, I'm going to multiply out the one side, so this will give me x squared plus 5x minus 6. And then it's a quadratic equation, which we have to make one side equal to 0, and factor or use your quadratic formula. In this case, it does factor nicely. And we get two answers. And just like every single logarithm equation, once you get your answers, we have to go back to the original equation and check. If I plug in positive 3, positive number inside of here, positive number inside of here, positive number inside of all three, this one is okay. And if I plug in negative 2, I get negative 12 in the first one. You don't have to check them all. As soon as you have a negative in one spot, you cancel it out. And again, a little bit frustrated with the textbook that they made the negative answer cancel out. It's possible sometimes that you do all the work and none of them work. You do a whole bunch of work, check your answers, and none of them work. This happened, oh, it's probably been about 8 years ago. I was like, that is me. On your provincial exam, the very first question on the entire exam was a log solving equation where you did a bunch of work, got your final answer, and when you checked, it didn't work. How does that make you feel confidence-wise on the very first question that you're like, no solution? They wouldn't do that to me. They did that. Yes, it's possible to get one with no solution whatsoever where both answers don't work. Or even maybe, I think on that one there was only one answer, but you did all that work and you're like, my confidence is shot. I just have no solution for the, I don't know, I want to start crying and I have 3 hours left on my exam, but that happens. So there are some times that when you check, it doesn't work at all. And there is actually no possible solution to the question. Sometimes both of them work. And it can be that the negative one works and the positive one doesn't. I will make sure that I give you an example like that moving forward so that you don't get into this idea that this is what would happen. Okay? So now I'm going to go back and not do the shortcut for this one. So I'm going to erase this answer. Because some people don't like shortcuts. So if I was doing this and I wanted to use the steps and I wanted a single logarithm, the very first thing I would do is I would actually put all of my logarithms on one side. So I subtract that log 6x to the other side. And then I would combine as a single logarithm. Remember, adding and subtracting, you can combine in a single step. Whatever is added, that'll get combined in your numerator. Whatever is subtracted, that'll go in your denominator. So we've done step one. We got our single logarithm. Okay? Step two. This is the step that's in purple with red stars. The base is 10. The exponent is 0. And the answer is x plus 6 times x minus 1, all divided by 6x. Now 10 to the 0 is 1. Maybe I'll multiply up the top. X squared plus 5x minus 6 over 6x. You can multiply both sides by 6x to get rid of this. And at this point, we got to the same spot as we did in our shortcut. We got to the same place where we went so, and they were both equal. So from here, everything else would be the same. It would be 6x. Thank you. So this part here with the purple step, if you have one side as 0, you still can change it. The base is 10, the exponent is 0, and remember that 10 or anything to an exponent of 0 is equal to 1. So it still works out. Some people like, oh, I don't want to have to remember a shortcut and the regular way, and I just want to remember one way to do it. Then get your single logarithm, change to exponential form, and then from there you can solve it like a regular equation. Oh, questions from the first one were 3, 4, and 9. And questions for the second one, 11 and 13. So you can circle all of those.